Okay, imagine you have a circular field, okay, and let's call this as a center. And now you have a goat tied with rope R, and the question here is what is the length of this rope, so that means what is the length of this R, so that the goat will only eat exactly the half of the area of this field. This seems very simple, right? So how do you start with? Okay, so this area, that means the area of the blue circle, will be pi into r square, and we want that area to be equal to the half of this area, which is pi into 1 square divided by 2. So from this you can tell that r is equal to 1 by root 2. But things will go little bit complicated when you actually tie the goat at an edge of the circle. Let me draw this thing. Okay, this is our circular field, and let's say the goat is this is, as usually, this is the center, and the goat is now started, instead of at the center, we tied that goat to the edge of the pole. Okay, so if you tie this at the edge, um, what could have happened is, yes, and let me erase the outer side. Okay, so this is the case. Now the thing is, you need to find the length of the rope for this guy from here to here. Okay, and the same goes down also, but I don't want to indicate there. Let's call this as R. Okay, so you need to find this length of R so that the area that is grazed by the goat, that means total this area, this whole half of, so this region should be eaten by the goat. So yeah, let's solve through it. So this is the actual problem itself. Here, it's very easy to find the radius of r when it is tied to center. But things will get a little complicated when you try to tie the goat at the edge of the circular field. Okay, so let's say it was tied here, and the length of the rope is r, and for a given r in a unit circle, it will always have alpha in it. Okay, and now the question here is, what is the length of the rope such that the goat will now exactly eat half of the area of the circle? Okay, so now you need to calculate the area enclosed by this blue curve along with these. So now our task is to find the area of this guy. Okay, once you know what is the area of this guy, we will make it equal to pi by 2. Then we can able to comment on what is the r and what is the alpha. Okay, so but before going to find out the area, let us start in an intuitive way, where we need to find what is the value of r, like the limits, how far that r can go, like the boundaries of r, you can say. Okay, so I would like to ask you this question, like, what will be the area if r is equal to 1? I want the area, what is if r is equal to 1. Okay, if the r is equal to 1, then obviously this blue circle should pass through the center, right? Because this length is 1 here. So the area could be, you don't have to calculate the area here to comment on what would be the area. Okay, we don't need the exact answers of it. So if the r is equal to 1, then obviously this blue line will pass through the center, and obviously that area will be less than pi by 2. Why? Because this is an arc that is passing through the center, and try to draw a diameter from the center, then that diameter, the whatever value which is on the right side after the diameter, is actually pi by 2, but here it is less than pi by 2, right? Because it is missing these kind of areas here. Okay, hope you understand this. And what would be, this is the lower limit. Okay, r should be greater than pi by 2. Okay, sorry, my bad. R should be greater than 1. Okay, that is one limit that we got. And can R be equal to root 2? Okay, if R is equal to root 2, what would be the area? Like, can you comment on this? This is also not that hard, because R equal to root 2, in the sense you are actually touching the R here. Let me draw this. Okay, uh, exactly here, right? Because this will make up 1, and the top guy will make up 1. 1 1 means this guy should be equal to root 2. Okay, so yeah, based upon that info, you can say that if that is R, that is obviously an extra area is coming than the area that is only there if you draw after the diameter, right? So obviously that area is greater than pi by 2, right? You just need to work it out, you will understand these two statements, uh, if you think so. Okay, so r can't be greater than root 2, it should be less than. So here we got these very beautiful relations where r lies in between 1 and root 2. That means 1 lies between r lies between 1.414. Okay, there is one value of r that is sitting between these 2 points, which gives exactly pi by 2. So now we will try to find the equation of the area, and then we will solve for what is the value of r. So as I already know the solution, uh, if you only try to do this problem in R, it will become a bit complex. It will have terms of square root and squares of R. So we better need to use alpha also in order to solve this problem. Okay, because if you know alpha, uh, basically in a given circle, if you know what is r, alpha is dependent on it, because you can't have the same r with different alphas actually. So for that, since you have alpha 1 and root 2 as the limits of r, you can also have the limits of alpha also. But before getting that, I just want to quickly give you the relation between R and alpha. I will highly encourage you to do this, because this is not that tough actually. Let me show you. Okay, sorry. Uh, if you draw a diameter like this, okay, and you know this value is actually alpha by 2, right? When this is alpha by 2, and the whole length is 2, because this is a unit circle. Once more I need to write. Okay, um, so once this is a unit circle, the diameter will be 2, and this is alpha by 2. We know that any chord placed in a circle, in a semicircle, will always does a right angle to the either end of the circles. Okay, this is what I mean. So you see this, right? This angle will be 90 degrees. Okay, so once you know this angle, it's very easy to comment on r, because r is actually adjacent side of alpha by 2. So we know that cos alpha by 2 is equal to r divided by hypotenuse, which is equal to 1 plus 1, which is equal to 2, and that will give you the relation between r and alpha, which is equal to cos alpha by 2. Okay, this is a very important equation. We are going to use it, okay, in future. uh, yes. So one more thing that I want to tell is, just like you have given the limits to r, you can also give limits to alpha also. Treat if r is equal to 1, the r the this blue color circle will pass through the center, and what could be the value of it? Okay, uh, try this thing. what are the values of alpha. But here I am giving you the answers. For r equal to 1, alpha will be 120 degree, and for r equal to root 2, alpha would be, what can I say, 90 degree. Yeah, you can try this. Okay, this is not that difficult. uh, it's very easy to solve. Okay, moving on to the next thing. We need to find the expression for the area enclosed by this blue guy. Okay, not only blue, also these edges, I mean. Okay, so let's do this. I have shown you here uh, actually a semicircle. Okay, because this is a symmetric around the horizontal axis. It's very easy if you know the expression for half of the circle, and you can just simply multiply it with 2 to get the full area. Okay, so in order to start with, uh, we'll first name these endpoints so that it will be easy for us uh, to find the area. A, B, C, and D. Okay, and let me also join these two. Okay, yeah. So to comment about the area grazed by that goat, um, you can imagine as three parts. Okay, the first part is the area of A, B, and C sector. Okay, you need to take this area, and also the area of this sector DBC. Okay, and once you add both of them, you have this extra overlap area of this triangle. Okay, of DBC. You need to remove that because you are counting it twice. Okay, so this is the area of the entire and you need to multiply it with 2 so that you will get the entire area of the field that is grazed by the goat. Okay, so to find the area of sectors, it's better, it is easy if you know the angles of those sectors. Okay, you know this. So this is r we talked about, this side, and this is alpha by 2 because the entire is alpha, that is what we defined here. And let me call this angle as theta. Okay, so and we'll call, okay, I will tell you when the equation comes. Okay, so to write that equation, it is, first equation is area of sector ABC plus area of sector DBC minus area of triangle DBC. Okay, after doing that, uh, let me write these equations here. uh, First of all, we need to find the area of sector ABC, which means ABC, which deals with this guy. Okay, so it would be the area of circle of that radius multiplied by the fraction of that angle to the 360. That will give the area of sector. Okay, so how would you write it? So pi into r square into alpha by 2 divided by 360, means you have to keep alpha as degrees. Instead of I will deal alpha in radians, so I will keep 2 pi. Okay, this is the area of ABC sector. In similar way, you can also find the area of DBC sector, where DBC is this side is 1 because this is drawn from center to the edge of the circle. This is a unit circle again, that's why the area of that circle will be 1. radius will be 1, so the area is pi into 1 square, and the angle is theta in radians divided by 2 pi, and minus what would be the area of the triangle. Okay, for that you need to find out the height, actually the height of this triangle. Okay, let me you can easily know that if you draw a perpendicular from the here, uh, and you can call this point as some e. Okay, so this height can be written in two forms, because you can write it as sine of opposite by hypotenuse, which is 1, which will give sine theta, and sine of alpha by 2 into which is equal to opposite by hypotenuse, which is r, which is equal to r sine alpha by 2. So this height, if you call it as h, it can take two forms. One is sine theta into 1, which is hypotenuse, or you can also write sine alpha by 2 into hypotenuse is r. Okay, so you can write these things, but and you should also remember that in previously we have derived the relation between r and alpha by 2, which is equal to r is equal to 2 cos alpha by 2. Okay, you just need to replace this r with this value, so that height will be only in terms of alpha, just like height is in terms of theta, height it will be in terms of alpha. So if you can write that h is equal to 2 cos alpha by 2 into sine alpha by 2, this looks like a familiar formula of sine 2 theta. Sine 2 theta is equal, not this theta, let's say sine x. Okay, sine x can also be written as sine 2x can also be written as 2 sin x cos x. So here x is alpha by 2, so this will be equal to sine 2x, where x is equal to alpha by 2, which is equal to sine alpha. Okay, sine alpha. So interestingly, we came here to a relation where h is equal to sine alpha, and it is also equal to sine theta. Okay, so we are going to talk this when the time comes. Okay, but just now, for now we'll keep the h as sine alpha and we'll proceed with this. Okay, so what is the area of triangle? It's half into base into height, right? Half, and base is equal to from d to c, which is equal to again the radius of the circle, which is 1, and height is what we got as sine alpha. Okay, nice. And yeah, I forgot to include here that this area is only the semicircle, and you need to multiply it with 2 to get the full area of the entire field grazed by that blue line. Okay, so here you can see there are plenty of things that are in common. You can cancel the 2 with all the 2's in the denominator, and we don't need pi on numerator and denominator. And yeah, so this will comprise you to this equation: r square alpha by 2 plus theta minus sine alpha. Okay, again you make use of this equation and put r and replace this with this equation. Okay, 2 cos alpha by 2 whole square into alpha by 2 plus theta minus sine alpha. Okay, you can take this 2 outside, because then you will get 2 into 2 cos square alpha by 2 can be written as 1 plus cos 2, 2 times of whatever the angle it is, so 2 times of inside angle is alpha. Okay, into alpha by 2 plus theta minus sine alpha, because this is the identity of cos. 2 cos square alpha by 2 is 1 plus cos alpha, and 2 sine square alpha by 2 is 1 minus cos alpha. Okay, those based upon that identity I have written this thing. uh, yeah, you can also cancel here the 2 on numerator and denominator, so final expression will turn out to be, uh, first I will write alpha cos alpha plus alpha plus theta minus sine alpha. Okay, and alpha plus theta can be written as pi. Okay, I will tell you how, but I would encourage you to find it on yourself. Okay, because alpha plus theta equal to so this is the total area, and this should be equal to pi by 2, because this is the half of the area of unit circle, right? Yeah. So yeah, coming to this, alpha plus theta is equal to pi, right? That came through this equation only, like sine theta and sine alpha. So we, from this equations, we came to this relation like sine theta is actually sine alpha, right? Because both are equal to h. So if you see a typical sine wave, right, it will somehow look like this. uh, okay, so the value is equal to h. Let's say height is some height, uh, if I can draw like this. Okay, so this is exactly bisecting, like you can say sine theta is equal to sine alpha. You can say sometimes like theta is equal to alpha, but this is not true for all angles. This will be only true for when both are equal to pi by 2 and minus, sorry, 3 pi by 2. That means for 90 degrees and 270 degrees. Okay, but this is not the only relation that satisfies this. There are two angles when theta is equal to 60 and alpha is equal to 120, then also they will have same height. Okay, because these are those angles, right? This is exactly where this 90 starts, and this is where 270. Okay, if you draw any number of lines, right, they will equally separate on this side and this side. So always you can guarantee that the summation of both of them is equal to 180. If you draw it at the exactly at center, the intersections will be at 0 and 180, and again the sum is 180. So in that sense, uh, I have directly written like alpha plus theta is equal to 180. But yeah, so this is the equation that we are going to use to find out the value of alpha. So once you know the alpha, you know the relation to that with r. So r can be easily find out. Okay. Yes. So to find out the solution for this equation, it even the solution for this equation is also not straightforward. Let me explain you. Okay, let me copy this and I'll paste it here. Okay, so you can also simplify further. Alpha cos alpha plus pi by 2 minus sine alpha equal to 0. Uh, and one more step, final step I want to do is keeping the alpha on one side and shifting everything to the other side, which will gives me this sort of value. Sorry. Okay, so this is alpha and this is something as a function of alpha. Okay, so this basically this equation structure itself, so these kind of equations are known as transcendental equations. Okay, so the definition for them is whatever you are trying to find out the solution for the equation, it is itself in the form of variable of it. Okay, but this should not be algebraic. It can be exponential, it can be trigonometric, it can be logarithmic. The examples will be something like this: x is equal to tan x, and x is equal to e power 3x, and or x could be equal to ln of x. So all these equations, right, uh, these are not algebraic. Okay, you need to expand them into Taylor series or you can find them, but there are other different ways of solving these kind of transcendental equations. So two such ways are bisection method and another is Newton-Raphson. Okay, but bisection method is what something I feel it's very intuitive and it's very uh, easy to understand to solve these kind of equations. Okay, so bisection method is something like this. You basically uh, make that equation in such a way that that f of alpha minus alpha is equal to 0, so that there is one particular value of alpha that if you substitute in this equation, that is going to give you an answer very close to 0. Okay, you may get which is exactly equal to 0 because that is the solution. In some times you may get a value which is very close to 0. That is still fine, it is up to the level of accuracy that you want. Okay. Okay, so these are some kind of equations. The basically the bisection method will deal in such a way that let's say this is a zero axis, this is the height axis, this is the zero, and f of alpha minus alpha looks like this kind of equation. Okay, that means there is one particular value of alpha, that alpha is equal to alpha naught, that where this value could be 0, but before that it might be greater than 0 and it will be less than 0 also. Okay, so you basically start with two different values, let's say alpha 1 and alpha 2. Okay, those should be in opposite signs, that means the value of this difference should be of opposite signs. Okay, you basically start with alpha 1 and alpha 2. So we know these limits, right? Because initially I told you what are the limits for r, and we came up to know that it should be less than 1 and less than root 2. And similarly with alpha also we got these equations, it should be less than 90 and 120, right? So these guys could be those values. Okay, you start with 90 and take that whatever value it is, and you also keep 120 and note down those values. Okay, once you know these things, then the next attempt, bisection method is actually an iteration method, because once you start with two values, so that you should guarantee that the output of those values should be one is positive and one is negative. That is, that those are the values which are above 0 and below 0, right? So once you start with that and you take the middle value of it, means you take alpha 1 plus alpha 2 by 2 and substitute it. Okay, if it comes above this thing, right, the next value is should be in between this value and the alpha 2, or if that value comes out to be negative, right, the next value should be between alpha 1 and that the alpha 3 value. Okay, so in this way you will move closer and closer to the 0, means whatever the latest values that are smaller in the heights and are closer to 0, if you do this process more and more, you will meet the value of 0. Okay, I hope you understand this, but if you don't, if you follow this process, you will easily understand. Okay, we will initially start with this table. Okay, uh, where one side we will write what is the alpha that we are taking, and the other side we will write the function, and the other side we will write the function. Yeah, so yes, the function would be sine alpha minus pi by 2 by cos alpha minus alpha, because this is the function, right? This is should be equal to 0. So we will stop at the point where the function is almost approaching to 0. Okay, so the points to pick of alpha 1 and alpha 2 are these things, 90 and 120. Okay, so if you initially start with 120, so 120, so since these are in radians, right, I'm actually writing these values, I have solved, so I'm seeing my copy here. Okay, but I would encourage you to do the same. You convert the degrees into radians and substitute them as the value of in this expression. Okay, so if you substitute 180, so sorry, 120, 120 is in radians is 2.094. Okay, if you substitute it here, you will get a value of minus 0.684. Okay, so So based upon this, so alpha 2 is my 120. If I substitute alpha 1 as 90, okay, but don't do it 90, because 90 cos 90 will be is equal to 0. So this value has a very large value. So instead of that, you can take any value like 95 or 100, whatever it is. In my case, I'm taking 100. So the radian equivalent of 100 is 1.745. Okay, if you substitute this value, I'm getting to be 1.629. Okay, so now for 2.94, I'm getting minus 0.68, and 1.74, I'm getting 1.63. Okay, so now I need to find an angle that is in the midway of this. That means you need to add both of them and divide it by 2. Okay, if you do so, you will land up at 1.9195. Okay, so if you substitute this value, I am actually getting minus 0.073. Okay, that means I am, if I taking the midpoint of it, I am actually here. Okay, so my next point should be where? It should not be between these 2 points, right? Because you will move away from 0 if you take this 2 point. You should always take points that are, one should be above and one should be below, and those values should be lesser and lesser as you go on. Okay, so if you try this, I need to take the midpoint of this one and this one. Okay, so the midpoint of these 2 points will be 1.8325. Okay, so if I substitute that into this equation, I will get 0.507. Okay, so this value now moved up, like I am currently now here. Okay, so my midpoint should be this point and this point. That means these 2 points. So if you solve for these 2 points here, you will land up 1.876. Okay, and this process continues. Okay, you just need to stop when you feel like the accuracy of output is still good. So but I'm just filling these numbers so that you will understand the flow. Okay, 897 gives a 0.0444. Okay, and then again it's the same thing, you are still on the point side. You should always do between this point and this point as you move on. So that will lead to 1.9089, and that is actually giving 0.00176. So now the next point will be between these 2 points, which is 1.9029. That is giving me a value of 0.015. And again the next point will be between these 2 points, 1.0 sorry 9059, and that is actually giving minus 0.001. So this is almost 001, means you can consider this as very similar to 0. So you can still continue, and it's up to you like how much accurate you want that alpha to be, because you can see a trend here, right? It initially started with 2, then hop off to 1.75, and it came to 1.9, 1.8, 1.7, 87, 89, 90, 90. See, you are getting an accuracy of 2 decimals here, and 908, 903, 905. If you go on, you will get a 3 decimal accuracy also. Okay, so for now I'm stopping here. So I got an alpha to be 1.9059. Okay, if I convert this into degrees, right? So I should multiply this with 180 by pi. Okay, this is actually giving me an answer of 109.2 degrees. Okay, so if you substitute this in the equation that we got, right? We got r is equal to 2 cos alpha by 2. Okay, so if you substitute this value inside this, you will almost get an answer of 1.158. Okay, this is the length of the rope uh, that make that goat eat exactly half of the area of that circle. Okay, and this is still true, right? Because the limits that we have talked about is 1 less than r less than uh, root 2, that means 1.414. So the value is 1.158. If you solve more of this, you will get even more smaller value. But yeah, so this is how you solve transcendental equations to find an answer. But this way of approach will only give you a approximate solution only. The exact solution is really hard. Okay, they have there are people who have defined this exact equation. I will send you the links in the description, where they have found out a way of finding the exact solution for this. And I'm also attaching a video based upon this equation, where he talks about this problem. And of course, he will show you how complicated this is, instead of trying in an approximate solution. Yeah, and thanks for watching.